oh, not too bad. So you obviously know what parallel lines are. They're two lines which are going side by side. So I'm just popping the two parallel lines here in green. And the way it's represented in a question that they are parallel lines, it will say in the narrative, but they'll also put that arrowhead on them to make it clear that they are parallel. So bearing in mind you've got parallel lines, there are 3 or 4 angle facts. So the first thing to take on board, all right, is just looking at one of the lines. So where you've got any 2 lines that are crossing, by definition, the 2 angles opposite each other are equal. And if you were being asked to explain why x is 64 degrees, the reason you would give is that vertically opposite angles are equal. So anytime you have any 2 straight lines crossing, you know any 2 opposite angles are equal. So I'm just drawing it again at the top, okay, to cross, and you will see that the 2 angles on the left and the right, which I'm just putting 1 dot in, they must be equal, but equally the angles that I'm just putting green dots in would also be equal. They'll come through in a second after a lag. And if a question, because quite often in part A of a question, we'll go and say, work out what x is, and you'd go and say 64 degrees. And then part B, it will ask you to explain why it's 64 degrees. And you've got to go and say that that's because vertically opposite angles are equal. So that's the first rule you've got to be aware of. Okay, vertically opposite angles are equal. Now, just moving on to slide number 2. Okay, I'll wait for it to click through for you, where again, we've got parallel lines. So again, I'm just going to highlight that we've got parallel lines. Okay, now this is a rule that alternate angles are equal. Okay, now this is also called the Z angle rule, and I forget whether we've covered this before or not, but it's in the scheme of work for us to look at it again. Alternatively, I want you to think of this as the Z angle rule. That angle inside a Z is the same as that angle there inside a Z. So what we could say with this particular question, if I go and do this Z there, then that angle there, the red dot, is the same as that angle there. So it's the 2 angles inside a Z. So once you've gone and worked out that x was 64 by saying that that's because vertically opposite angles were equal, if the question had gone and asked you to work out what angle W was, which I'm just popping in there, that angle W, you would say, well, that's also 64 degrees. And the reason is that alternate angles are equal. So it all depends on what information you're given in the question. Sometimes you will be using this Z angle rule because you've got one of the angles inside the Z and you need to work out another angle inside the Z. Now, you're going to have to learn that this is called the alternate angles are equal. And I just want to give you some imagery to sort of imagine it. Imagine you're looking down from above, and that Z shape is a fence, or sort of in a prison or something. All right. And those 2 red dots are 2 people sitting down, regretting the fact that they're in prison. OK, that dot at the top is he's looking out to the left. And that dot at the bottom is looking out to the right. They have got alternative views. They are looking in alternative directions. Okay, so if they're on some island somewhere where there were prisoners and there were fences, they'd be looking out in opposite directions out over the sea. So that's just a bit of imagery to help you remember that the Z angle rule, because you can't call it the Z angle rule, that's slang. All right, you've got to go and say, if they go and say, why is that your answer? You've got to go and say, because alternate angles are equal. So that's rule number 2. Now, thirdly, we're going to have this one called corresponding angles are equal. Now, this one in slang, this is the F angle rule. So the angles inside a falling over capital F would be the same. Okay, so for example, there is my F. That angle where I'm putting the 2 dots on is going to be the same as that angle there that I put the 2 dots on. Okay, so, and then you would go and say that's because corresponding angles are equal. And keeping the same imagery as before, if you imagine that falling over F is the fencing, and you're looking down from above at a prison. That prisoner is looking to the right. That prisoner there is also looking to the right. They have a corresponding view. They have the same view. So whenever you want to think of it as saying, well, that's the F angle rule, you've got to write down that's when corresponding angles are equal. Now, just to note, this F doesn't have to be conveniently that way round. Okay, it could be, but equally the question could be that the F is upside down. So imagine the question was such that it looked like this. All right. We were given that 64 degrees there, and imagine the wording of the question was such that we had to work out that angle there, which I'm going to call W. Well, that would now be looking at it as an upside down F, and that's absolutely fine. Those two angles inside the capital F are the same. So we could go and say that W is 64 degrees, and the reason is because corresponding angles are equal. Okay, so we had vertically opposite angles are equal. That's when it was just a cross. We had alternate angles are equal. That's when it's like a Z shape. And thirdly, we've had corresponding angles are equal when it's like this capital F. So a couple more bits that I've noticed to come up on the worksheet for today. So number 4, if you've got a parallelogram, and remember what a parallelogram is, that's where you've got two sides are parallel, two opposite sides are parallel, and the other two opposite sides are parallel. Where that's the case, okay, opposite angles in a parallelogram are equal. So that angle there, which is 65 degrees, must mean that that angle there is 65 degrees. So if you've got questions involving a parallelogram, remember that opposite angles are equal. You will be needing to use that skill. And again, having had a flick through the questions that I've set for you on Dr. Frost, the final thing that you might need to bring into your toolkit, okay, is to remember what's going on with an isosceles triangle. Oh, I spelled that wrong, sorry. That should be I-S-O-S-C-E-L-I-S. It's an isosceles triangle are equal. So remember what an isosceles triangle is. You've got two sides the same, and we tend to represent that by there being a little dash on it, but the third length is a shorter or a longer length. So with an isosceles triangle, two sides are the same, but also two angles are the same, and it's these two angles here. Okay, so it's not the angle where the two lines with the dash join. It's the other two angles that are equal. And again, so if we knew this one here was 80 degrees and they were asking us to work out what X is, we could go and say that X equals 80 degrees. And the reason we would give, you would write down, is base angles of an isosceles triangle are equal. So I feel that all the questions in today's worksheet can either be answered using these 4 facts we've covered today, or alternatively, all the angle facts we covered in our revision lesson. So that was like angles in a triangle add up to 180, angles in a quadrilateral add up to 360. What else was there? Angles in a straight line add up to 180, angles about a point add up to 360. So all of that stuff. So what I would like you to do, please, is to go and have a look at today's worksheet. And if you get that finished, just go back and make sure you completed yesterday's angles worksheet as well. Okay, so as always, I'll stop the recording now. Okay, so stop the recording. And that's now stopped, and I will go